You'll miss this joke you'll miss this joke someday. And Cirque. How much work is done on the box? When I'm lifting something, work is given by force times distance, but we've said, you know what? It's mgh. And now with the work energy theorem, what I'm really saying is you're giving it potential energy. The mass is 688 kilograms. That's a big box. G is 9.8. H is 2.4. So I get 688 times 9.8 times 2.4. You get 16,181. I'm going to go 16,200. Is that correct? And that would be joules. 1 mark. How much power is generated? Well, power is work over time. Emma, did they give me a time in this question? Oh, so I'm going to take my answer. I'm going to write 16,200, but you know I'm going to use my answer button. Divided by 45. You get 360, 359.6. I'll go 360. Power is measured in watt. How much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? This is the piggyback when I had Cole piggyback Nick. And the reason is when you carry something, the force you're resisting is gravity, but the distance that you're moving is forward. You have technically, in the physics definition, not done any work. You'll only be doing work if you change that object's height, or if you change its speed. I don't see a mention of a change in speed here anywhere. 2 marks. An electric motor develops 65 kilowatts, that's 65,000 watts, of power as it lifts a loaded elevator. How much force? Well, power equals work over time. And I know that work equals force times distance. So it seems reasonable to me, Emma, to say power is also force times distance over time. I'm guessing because it does set how much force. I did a quick check. I think I have all those numbers. I'm going to get the F by itself. Apparently force, yet another way to calculate force. Again, Chloe, don't memorize this. We can derive it if we need to. Apparently it's power times time divided by distance. It's going to be power 65,000 watts. 35 seconds divided by 17.5. Am I on the right track, folks? Hope so. 65,000 watts times 35 divided by 17.5. Do you get 130,000 even? That's kind of nice. We'll take that. 130,000 newtons. If you got that, 2 out of 2. Otherwise, I would probably go something like this. I think I would give you half mark for that, half mark for that, half mark for that, and a half mark for the answer. I don't know. Something like that. Next page. Find the kinetic energy of the bullet. Kinetic energy is a half mv squared. It's going to be 0.5.0042 times 965 squared. You get 1955 point. Can I go 1,960 joules? Suppose the bullet starts from rest. What work is done on the bullet if it starts from rest? That much work. What's the average force acting on the bullet? Well, work equals force times distance, so force equals work over distance. So it's going to be 1960 over 0.75, except I'm going to use my answer button. Do you get 2,610 newtons? People nodding? No? Yeah? Okay. Okay. A shell is shot from a cannon at Earth's surface to a height of that. What's the potential energy? Potential energy is mgh, so it's going to be 50 times 9.8 times 4 times 10 to the 2 is 400, and that's less typing. Do you get 196,000 joules of energy? 1 mark. What's the change in potential energy? Oh, what's change in anything? So this is going to be potential energy final minus potential energy initial. It's going to be mgh final minus mgh initial. I already know mgh initial. It's 196,000. And mgh final is going to be 50 times 9.8 times 200. I think it's just going to be half of this, but it's going to be negative because you've lost energy. That's your change in. But let me just see if that works. 50 times 9.8 times 200 minus answer button. Yeah, do you get negative 98,000 joules? Why negative? This object lost potential energy. Where'd that energy go? Well, not most of it. Some of it went to heat. Where'd the rest of it go? No, missing the obvious. Darn right, kinetic. This thing is going way faster than it was up there. As it falls, it speeds up. Right? That was too obvious. It went into kinetic energy. Half mv squared. Oh, we got more. Good. Bike rider approaches a hill. Find the kinetic energy. Ke equals a half mv squared. 0.5, 85, 8.5 squared. You get 3,070, 3,071, 3,070.6, whatever it was. At what height will the bike come to a stop? This is a job for conservation of energy. What I'm really saying is I'm going to start with some Ke, I'm going to start with some Pe, I'm going to end with some Ke, I'm going to end with some Pe, except I know that my initial potential energy is 0 because I'm starting on the ground, and my final kinetic energy is 0 because it says coasting to a stop. So really what I end up with is 30,070 equaling mgh. H is going to be 30,070 divided by mg. It's going to be this number divided by bracket 85 times 9.8. You get 3.7, 3.69. Anybody nodding? A couple nods? Good. Last one. Oh no, 2 more. What happens to its kinetic energy if we double its velocity? It gets how many times larger? Why? That's squared. What if we triple its velocity? How much more energy do we need to do that? 9 times more energy. 9 times more energy. All right. A. How much kinetic energy will it have when it reaches the bottom of the hill? So we have this conservation of energy. G. I should slow down. Reading this, Michael, here's what I said. Is there a change in height?
Yeah.
Is there a change in speed? Is there a yucky, curvy path? I see kind of a rampy thing. This is a job for conservation of energy. G. So it's going to be kinetic initial. Potential initial equals kinetic final. Plus potential final. Michael, are any of these zero? I think I'm going to say we start on the ground. We don't end on the ground. We're ending at the... Oh, no, hang on. Sorry. I did that totally backwards. We end on the ground. I was reading this question completely wrong. I should have dulped. And I think we're going to assume our initial kinetic is 0. We're starting at rest. So I'm going to get this. mgh initial equals a half mv final squared. Ooh, Michael, what do you notice about the masses? So, although they told me the mass, they didn't need to. And I want to get the... Geez, Duick, I'm doing B already. I got to read this question carefully. Hang on, hit the wrong button there, Mr. Duick. Let's try that again. Okay, let's try all this again. Undo. Let's clue in, Mr. Duick, that this is part B. Because I'm on my way to finding V. All part A wanted was how much kinetic energy. The kinetic energy is going to be the mgh that we started with. Yeah? Okay. So I know kinetic energy is normally a half mv squared, but really I'm saying here kinetic energy final is going to be equal to potential energy initial. It's going to be m 3.5 times 9.8 times 2.3. Sorry, is the answer to A 78.9? Yeah. Boy, did I not read that question carefully. I still do that once in a while. Dumb. Now, B wants the speed. Let's find the speed. Michael, coming back to you, how would I get the V by itself? Yep. 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 It's going to be 2 times 9.8 times 2.3 square root. We're going to be going 6.7 meters. 6.71 meters per second. Okay. Could you give yourself a little score at the top of the page out of 16, please? Last day, we said that work equals force times distance, and work equals the area underneath the force versus distance graph. But work is also the change in potential plus the change in kinetic. And I use this one when they say how much work and they don't give me a force and a distance or a graph. So we did example 1, except we did example 1 incorrectly. For a candy, does anybody spot the mistake that Mr. Duick allowed us to make and didn't catch himself because he was trying to do stuff in his head? Why is 1 incorrect? Yeah.
The bike weight.
Yeah, we didn't include the mass of the bike. We used the mass of the person of 65. We should have included the mass of the bike. So how the heck are we going to fix that? We're going to be incredibly, incredibly lazy. Are you ready? We're going to go like this. If you want to here, go 65 take away 7.2. If you want to change and make it say a cyclist weighs 57.8 kilograms, and there, now we're correct. We are. There. Now we've included the mass of the bike because 57.8 plus 7.2 is 65. Ta-da! And I should have caught that, although you should have caught that too. Some of you should have spoken up. Did you notice it at the time? You didn't say anything? You just let us be wrong? You're not my friend. We said that in this question they were asking how much work And so what I said last day, Emma, was our brain goes through a 3-step checklist. I always think force times distance first. We looked, there was no force in newtons, there was no distance. That didn't help us. Then I think maybe it's the area underneath the graph, no graph. And then we use this thing called the work energy theorem. So we left off all the way over, we saw a pretty cool motorcycle video, or we saw somebody risking their life. We got to example 4. I did finally live up to my promise to you. We revisited the RCMP question, and we did it more realistically. We said you can figure out how fast someone is traveling just from skid marks alone. A rocket car is initially at rest on a frictionless horizontal surface. The engine is ignited, and the graph below shows the thrust force versus distance. I guess the force is constant for a while, and then as the engine starts to burn out, the force gets less and less and less. Does that make sense, Tristan? Oh, there. Why do you think the force decreases after 15 minutes? What did we say? What do we think? Right, engine's burning itself out. You run out of, it's not gunpowder, rocket fuel. And now we're going to put it all together. Christy, what does B want me to find? After when? Okay. Wow. Well, I might think like VF equals VI plus AT. Do you see a T in here anywhere, Christy? No. I might think VF squared equals VI. Wait a minute. What did they ask me to find? They didn't say velocity. They said what? Which suggests a scalar approach. What kind of a graph is this? What's on the y-axis? What's the F stand for? You'll figure it out. Yes. What's on the x-axis? This is a force versus distance graph. You know what the area underneath this graph is? Work. So you ready? We're going to write this. Work equals work. I'm pretty sure that's correct. Can't argue with me on that one, Tristan. But now we're going to write work 2 different ways. The first, on the left, we're going to say area, and I'll just write the word area. Work is what times what? Jacqueline. I might try that, except what do they want me to find? What was our third definition of work from the work energy theorem? And does kinetic have speed in its equation? Ah! Chris, you see how we put all that together? It was a fairly lengthy chain of reasoning. It does tell me that the surface is horizontal, so are we gaining any potential energy? Are we gaining any height? Is there any change in potential? Tristan says no, so I can do that. Now, Christy, it says find the speed of the car after when? How far? You know what? It's this area here. Yes? Not the triangle, just the rectangle-y part. How do I find the area of a rectangle? Anyone? How do I find the area of a rectangle? And I will expect you to know this. Base times height or length times width, it's the same thing. So this area, I'm going to argue, Emma, is 15 times 160 times whatever the heck that is. That equals, what's changing anything? So it's going to be KE final minus KE initial. Psst, psst. What does that mean, Brian? Yeah? That was nice. Christy, what's the equation for kinetic energy? And can you, on your calculator, go 15 times 160? I should be able to do that in my head. Shouldn't I, Mr. Duke? 16 times 16 would be 216, so it's going to be less than that. 20,100? No, I'm off. Is it 2,400? I was way off. Forgot to carry a 1. Michael, does the mass cancel this time? No, because there's not an M hidden in the 2400. Okay. How do I get V by itself? Folks, how do I get V by itself? You can divide by 0.5 M. I'm fine with that. I'm going to times by 2 and divide by M because to me that looks prettier. Okay? So I'm going to say 2400 times by 2 divide by, what was M, Brian? Thank you. And that equals V final squared. Emma, how to get rid of a squared? Yeah. Remember how weird all this was all those months ago? Hopefully we're getting pretty comfy with this now, yeah? It's a much better way to learn. By the way, you can also use this trick in chemistry quite a bit too, I think, and cut down on your memorization. How fast is this rocket car going after 15 meters? You get 30.4? Yep. It's going pretty good. Nick, what's C want me to find? It's going to be the same as B in that look up. We're going to think to ourselves, work equals work. We're going to find work two different ways. We're going to find an area, and then we're going to use the work energy theorem. We're still going to say that it's a horizontal track. We're still going to say that we start off at rest. So let's make a little note here. Same as B. And Nick, I'm going to pick up, if it's okay with you, right on this line here. So I'm still going to have equals a half mv squared, but the area is going to change. Now it's not just the rectangle, it's the rectangle plus the, what's the shape right next to the rectangle, Nick? Sesame Street is brought to you by a triangle. So it's going to be 2400 plus, how do I find the area of a triangle? Cool? Base times height divided by 2. So it's going to be 2400 plus, what's the base of that triangle? How long is the base?
10.
Yep. What's the height of that triangle?
60.
Is it 160? Divided by 2. That's going to equal a half mv squared. Can you crunch that left-hand side for me, folks? What is 2400 plus 10 times 160 divided by 2? Make sure you do your order of operations properly. Although most of your calculators will do that for you. Emma, you're right. I should be able to do this in my head. I felt you glaring at me. It's going to be 800. Is it 3200? Equals, Nick, a half mv squared. Yes?
Yeah.
I'm going to get the v by itself because it's last block and some of you are getting a little tired and blinking for longer and longer and longer and longer and longer and longer sessions. Not that I'm mentioning any names. How would I get the V by itself?
Divide M.
Where? On the bottom or on the top? You can either put a 2 on the top or a 0.5 on the bottom. Just don't put a 2 on the bottom. Except that's not quite right. Yeah, good. I knew you'd get it. Okay. By the way, think about what we've done here from a graph and some basic data. We're predicting how fast an object is going. We don't even know what this object is. We don't know what the gunpowder is. We don't know how strong the rocket is. But from the law of conservation of energy and from our definition of work and good data, we can make some good predictions. And if you replace rocket car with dragster, now you're starting to do some pretty good engineering. Two times 3,200 divided by 5.2 square root. You get 35.1. What we're really saying, if you want to think about this in terms of conservation of energy, all of the energy stored in the rocket engine has been turned into kinetic. How much kinetic? Enough, a half m 35.1 squared of kinetic. That much. What's your homework? I have a take-home quiz for you. I said last day you could try 1, 2, and 3. You can try 4. You can try 6. Yeah, 9. You try 9. 10 is a lot of work. I'll pass on 10. So I assigned 1, 2, 3, 4, skip 5, 6, skip 8. What happened to number 7? I don't know. Do 9, skip 10, and you're going to get a take-home quiz as well.